All right, let's dive right in. Today, we're going to break down a really fundamental concept in Java, I/O streams. It sounds kind of technical, but it's actually Java's super clever solution to a really messy problem. How can one program talk to a keyboard, a file, and a network all at the same time without the code becoming a total nightmare? Let's get into it.
And this whole explainer actually came about because of a direct request from Dr. Sasan Azizian. He asked for a simple guide with simple examples specifically for his students. So that's our mission today, to make Java streams crystal clear for everyone. So to really get why streams are such a big deal, we got to go back to a huge problem programmers face. Pretty much every program you'll ever write needs to handle input and output, or I/O, right? But it has to talk to all these different kinds of devices.
Just think about it for a second. Your program might need to read what you're typing on a keyboard, or pull data from a file, or get info from a server halfway across the globe. Under the hood, those are all completely different operations. So how on earth do you write code that can handle all that without becoming a huge, complicated mess?
Well, the answer is Java's brilliant solution, streams. You can honestly think of them as a kind of universal translator for data. So what is a stream, really? At its heart, it's an abstraction. Now, that's a word you hear a lot in programming, but all it really means is hiding the complicated, messy details behind something clean and simple. A stream lets your program send or receive information without having to know anything about the gritty, low-level details of how a keyboard or a network card actually works. Okay, to really wrap our heads around this, let's use a simple analogy that makes this whole thing super clear. Just imagine a stream is like a conveyor belt, but instead of moving boxes in a factory, it's moving your data.
Here's how it works. First, a source, say a file on your computer, places little pieces of data onto the conveyor belt. Then, the stream, that's our conveyor belt, just moves that data along. And finally, at the other end, your program, the destination, just picks the data off the belt. And here is the magic part. Your program has no idea where that data came from. It doesn't need to care.
And that, right there, is the real power of that abstraction we were talking about. The code you write to read from the stream is exactly the same whether the data is coming from a keyboard, a file, or some server on the other side of the planet. This uniform, consistent approach is what makes your code so much cleaner and way, way easier to manage.
Okay, so now we get what a stream is. But it turns out they come in two main flavors. Each one is designed for a totally different kind of data. We've got byte streams, and we've got character streams. Let's start with the first one, byte streams. Think of these as the bedrock, the absolute foundation of all input and output in Java. Everything else is built on top of these. Byte streams are all about handling raw, unfiltered data. They work with 8-bit bytes, which is really the basic language that computers use to talk to each other. This makes them absolutely perfect for any kind of data that's not really meant for a human to read directly. Things like images, sound files, or compiled programs. And that brings us to our second type, character streams. Now, if byte streams are for machines, you can think of character streams as being designed specifically for us humans. Why? Because they're all about text. So here's the key difference. Character streams actually understand things like letters and symbols. They work with 16-bit Unicode characters, which means they can represent text from pretty much any language in the world. And the best part? They automatically handle the tricky job of converting raw bytes into the characters you see on screen. So if you're working with a text file, this is definitely the stream you want to use. Okay, theory is great, but let's get practical. We've met the two main types of streams. Now for the most important question. When you're actually sitting down to write some code, how do you decide which one to pick? Well, it turns out it all boils down to asking yourself one really simple question every single time you need to do I/O in your program. What kind of data am I actually dealing with here? And the answer is refreshingly simple. Look, if you're working with raw data that's meant for a machine, like an image file, a sound file, anything like that, you use a byte stream. But if you're working with text that a human is supposed to read, you use a character stream. That's it. That's the main decision you have to make. So, if there's one big thing to take away from all this, it's this. Java streams are an incredibly powerful abstraction. They take something that is fundamentally complicated, talking to all sorts of different hardware, and they make it simple, consistent, and so much easier for you, the programmer. And that leads me to a final question I want to leave you with. We've seen just how powerful this idea of abstraction is with I/O streams. So, as you continue on your coding journey, just think about this. Where else could you apply this same idea?
hiding complexity behind a simple front to make other really difficult problems much, much simpler to solve.
And finally, a huge thank you to Dr. Sasan Azizian. It was his request for his Java students that inspired this whole explainer. We really hope this made a big concept feel a lot simpler. Thanks so much for watching.